Hey everyone, my name is Sahil, and in today's video, we will discuss the various quality tests of medium voltage tension clamps carried out as per BSEN 50397 Part 2. But why should you listen to me? At Axis, we've been manufacturing and supplying overhead line hardware, including covered conductor accessories, for more than 30 years. Our products are trusted by more than 80 utilities across India, Africa, and Latin America. So, let's get down to business. First, let's start by understanding tension clamps. Also known as anchoring clamps, they anchor and terminate covered conductors at the end of a line or at points of directional change. This is designed to accommodate the required size of the covered conductor without compromising the insulation or structural integrity of the cable. To make sure your tension clamp performs as expected, it must pass the following tests. Firstly, the load test. This test checks whether your clamp can carry the mechanical load without causing deformations and affecting its function. So how do you conduct this test? The fitting is placed in a tensile testing machine using the test arrangement defined in the standard, and the load is applied gradually. The load is increased up to the specified mechanical minimum damage load, commonly known as SMDL, which is the maximum load the clamp should withstand without permanent deformation. The load is maintained for 60 seconds and the clamp is observed carefully. If any permanent deformation occurs at or below the SMDL, the test fails. After this, the load is increased to the specified minimum failure load, commonly known as the SMFL. And please note that this is the failure load, whereas the previous stage was the damage load. The load is again maintained for 60 seconds and your clamp passes the test if no failure of the fitting occurs. The second test is the tensile test at ambient temperature. This test checks whether your clamp can hold the covered conductor under high mechanical load without slipping or failing. So how do you conduct this test? Install 2 tension clamps on the covered conductor as used in real applications. Keep a minimum distance of 100 times the conductor diameter between the clamps, and maintain a free tail length of at least 500 mm on the unloaded side. Then, you mount the assembly on a tensile testing machine and conduct the test at ambient temperature. Apply an initial load and mark the conductor at the point where it leaves the clamps. This helps in monitoring the movement. Gradually increase the load and hold it for 60 seconds without adjusting the clamps. Increase the load further until SMFL is reached, and then maintain the load for another 60 seconds. Your clamp passes the test if the conductor does not slip more than 3 mm before reaching the SMFL. If you're finding these tests helpful, please subscribe to our channel for more insightful videos on electrical engineering. Now the third test is the climatic aging test. This test shows how the tension clamp will perform under harsh climatic conditions. To conduct the test, place 2 tension clamps in a test chamber and expose the clamps to 6 climatic cycles over a period of 6 weeks. During each cycle, the samples are subjected to luminous radiation and temperature variations as mentioned in the standard. After completing all the cycles, carry out a visual inspection followed by a mechanical load test. The clamp passes the test if there is no visible damage, all markings remain clear, and normal function is not affected. The clamp must also meet water tightness requirements after being kept under water for up to 12 hours and pass the required mechanical load test. Now we get to the last test, the corrosion test. This test checks whether the tension clamp withstands saline and coastal environments without corrosion damage. To conduct this test, place 2 tension clamp samples in a salt mist chamber in their normal service position. Expose the clamps to salt mist for 4 cycles over a period of 4 weeks. After the exposure, remove the samples and visually inspect all metallic parts and markings. Your clamp passes the test if red rust appears on less than 10% of the exposed metal surface, and corrosion does not affect normal operation. After the salt mist exposure, the clamp must also pass the required load test, confirming that it remains mechanically reliable in corrosive environments. I hope you now have a brief idea about the tests required for these medium voltage anchoring clamps. Axis MVCC solutions are designed to perform across all standard conductor sizes from 35 to 240 square millimeters. At Axis, we are proud of our contribution to rural electrification projects in more than 50 discoms across India, Africa, and the globe. Axis products were critical to the success of government schemes like Saubhagya and currently during the RDSS project as well, playing a key role in enhancing electrical infrastructure around the world. If you found this video helpful, please give it a like and subscribe to our channel for more insightful videos on electrical engineering. Before you move on to your next video, remember that even the best tests can't compensate for inadequate installation. Watch this video to learn about the correct installation procedures for anchoring clamps.